Climate change is a major issue for global manufacturing companies and logistic operators, whether that is through pressures created by the increasing awareness of customers and end consumers, higher costs derived from carbon taxes and the increasing cost of input materials, or the increased severity and frequency of extreme weather, resulting in, for example, low water levels in the Rhine in 2018. Shippers are, of course, already taking a number of actions. They're looking at their manufacturing processes to become more energy efficient and reduce water consumption. They're integrating environmental thinking into their product and packaging design, and they're reducing their carbon footprint across the supply chain. These are just some of the examples of what's happening today. We're pleased to have three speakers leading us through today's seminar. First of all, Professor Christoph Matulla, a climatologist and theoretical physicist at ZAMG, the Central Institution for Meteorology and Geodynamics in Vienna, where Christoph is team leader on climate impact. Secondly, we've got Professor Alan McKinnon, head of logistics at Kuhn Logistics University in Hamburg. Alan has been involved for over 4 decades with promoting the research and development of logistics in academia and industry. And thirdly, we will finish with Jürgen Hasler, head of mobility and logistics at BDI, the Federation of German Industries, and therefore in an excellent position to give us an overview of the concerns and actions of industry and shippers to climate change.
My name is Christoph Matulla, and together with Evan, we decided to briefly highlight a procedure that was established over the bygone, say, 16 or 18 months within a cooperation between the federal ministry responsible for public protection in Austria, the University of Vienna, and the Austrian Weather Service. These few facts I'm going to present you now will provide you with a framework so that you can judge yourself on your own statements spread by the media, which may be like we must keep global warming below 2 degrees Celsius, when others don't know what 2 degrees Celsius actually mean and why. So this will provide you with a framework which should be usable for you as well. We see we are here now, so that's present day, and back into the past we move left out, and we see the bygone 800,000 years of global mean temperature changes, right? And I think, according to my school education, that mankind, I mean, Homo sapiens entered the stage somewhere here. So, I mean, this is the period which is most important for mankind. Whatever happened before is only in so much important as that it paved the floor for our appearance, so to speak. And during this period of time, we see that global temperatures rather periodically moved from very low levels, which were attained in so-called ice ages, to high levels, which come with so-called warm periods. And there is much to say about, but I can't right now. And well, here it is. So the last ice age was the so-called Weichselwurm, where we left behind 24,000 years ago, I think, the Neanderthal. So if you see a person you think is a Neanderthaler, it's not, because we are only Homo sapiens on the planet right now. Anyway, that's what was a joke. And so for 12,000 years ago, we entered the Holocene and speeded in our evolution tremendously up. I mean, we started from Stone Age here and have achieved height of that may be summarized by Trump, I should have said by spacewalks, right? So it's a tremendous evolution that we did in this period, in this one period. And the second thing to know, of course, and you know that, is that CO2 levels in the atmosphere, CO2 lets through the atmosphere solar energy, stellar energy, but traps the energy that is sent off the surface of the planet towards space. So that gives us an additional warming. And in fact, we are very glad for that, because without this so-called greenhouse gas effect, we would have temperatures on Earth would be minus 18 degrees Celsius, and not the lively 15 plus, which makes this planet a nice place, a nice home for us, or to us. And so CO2 levels or concentrations in the atmosphere and temperatures are very, average temperatures, average global temperatures are very closely linked. And I've highlighted this by plotting this more significant part of this left figure once again, and displayed CO2 levels in blue and temperature levels, global mean temperature in red. So this is the bygone of 400,000 years. Here we are now, and back in time, we have to move leftwards. And what's about the concentration levels mankind has experienced and survived successfully so far? Well, think of the ice ages. We see that in ice ages, levels were about 190 parts per million. That means if we cut out some volume of air from the atmosphere and start counting particles, then we would have found 190 parts per million during the ice ages. And during the warm periods, we would have found 220. Okay, and presently we see levels above 400 parts per million. And to indicate how far this is outside the range which mankind has experienced so far, I've indicated this by this yellow dot. I hope, honestly, it's visible. So it's more or less, it's far off the natural range of variability. Okay, now next point, the pace of change. So in order to point this out, I've thought about highlighting the steep rise in temperature, which took only several thousand years from the Wechselwürm, the last ice age, towards the Holocene. So we rushed through 10 degrees Celsius in only a few thousand years. But presently, the change we are observing presently across the bygone, let's say, 150 years is 20 times that fast. I mean, an accident with a car at a speed of, let's say, 10 kilometers per hour is not likely to do much harm, but the same at 200 kilometers per hour is hard to survive, I'd say. Okay, so another fact, of course, is mankind turned into a significant climate driver. Well, just as the CO2 levels are climate drivers, mankind turned into that as well. And by saying that, I mean, considering the bygone 150 years, when we consider temperature changes, that means that a large fraction of this change is to be addressed to mankind's activities. There is much more to say about it, but I have no time to do that. And the other extreme is the so-called 2 degrees Celsius goal, which refers to the International Convention on the goal to keep global warming below 2 degrees Celsius until 2100. It was done in Paris in 2015. So we use now these changes or these developments of CO2 concentration in the atmosphere to drive global climate models. Global climate models are substitutes of the climate system. I mean, with the climate system, we can only do one experiment. We cannot turn back time. So it's good to have something which mimics and helps us to answer if-then questions. So if we follow, for instance, this business as usual pathway, then the consequence in 2100 would look like this. It's a significant change of global temperatures, which have, of course, a spatial pattern across the globe. It's a significant difference to our children or grandchildren living in this kind of condition than living in the kind of condition which comes with the 2 degrees Celsius goal. One point is left. These results carry significance only on large scales, right? They carry significance only on large scales. but not on regional and local scales. But when we speak of climate change impact, we need to have information on the local scale, because we are worrying about, let's say, a bridge score, about things happening on a local scale, influencing our business. And in order to do that, there is one more step required. This is the logo of Hans von Storch, who will attend the General F&L Assembly in Hamburg later this year, which was already introduced by Philip. And he's one of the great eminences of climate research. He had introduced many concepts and pushed forward this research very far. So this step, downscaling, we need to carry that out as well in order to achieve results valid on the local scale where the impact takes place. Okay, so with this slide, there come only two main points. I begin perhaps with the less obvious. The pictures, one group of pictures refers to extreme weather phenomena on one hand, and the others to damage events and losses to our business on the other hand. Now, the very prerequisite of any effective defensive strategy is to know the enemy. And that's the central pillar of our procedure as well. And in order to detect which weather pattern trigger hazards to our assets, we need good data on weather as well as on damages. So that's one central point. And by blending this information and carefully analyzing this data, we are, it's possible to identify the culprits. It is weather sequences which we call climate indices, which trigger or initiate processes harming our business. The second message is that impacts are felt across all modes. It's felt by roads, rails, deep sea, and inland shipping. So there is no way to escape, so to speak, no safe mode which will not and is not being affected by climate change. So that's the main messages. And the question that arises naturally is how to tackle climate change challenges, how to provide more security, whatever. And the official answer to that is mitigation as well as adaptation are both strategies which we need to apply in order to face the challenges coming along with climate change. And I'm very glad that Professor Hans von Storch will turn to this point as well, because there's much to say and it's kind of curious. And well, mitigation means what Philip already said, reducing our footprint, our carbon footprint and so on. And adaptation, of course, means, dealing with the impacts. And our procedure, which we will now briefly outline in this format, deals with the question how to best protect, how to attain best protection. This is a brand new procedure, which has been already successfully applied to Austria's most expensive and extensive project in public protection since World War II. And we have passed examinations and so on and so on and so on. So it's we are very, very proud of that, honestly. And it was, of course, the students can be very proud of themselves. And they have learned that 24/7 doesn't only apply to internet shopping, but to serious work on scientific problems as well. Anyway, they did a wonderful job, and we are right now we are very happy because we just learned a few days ago that it's accepted, that this paper, the significant paper, is accepted for publication in a very, very high-rated journal as well. Okay, so we're very proud of being pioneering in this field, and of course, we are in touch with F&L since some years, and we are very glad, from our side at least, for this intense exchange. And we would like to pull together to see whether it makes sense. I would like to show you now the steps that have been successfully attained in public protection. That's the first one is, of course, the blending and the detection of the culprit. And these are sequences of, in this case, of, for instance, of precipitation, daily precipitation totals over a period of a week or 8 days. Yeah? And these sequences characterize processes or weather sequences which very likely induce flash floods or flooding events at that very place which we investigated. That's the place of the very large investigation or public protection project in Austria. The second step, if I can remember correctly, of course, is that we carry out all steps which I already gave hints to. That means selecting which pathway of mankind we want to look at. And then retrieving GCM projections, which are valid only on the large scales, and then downscaling it, which sounds easy and is easy to be said, but is very hard to attain. It's much work. Okay, but in case we have this, that means we have on hand ensembles of local scale climate change projections. So climate change projections valid on the impact scale, we can detect or evaluate these so-called hazard development corridors, right? And they tell us the risk or the amount of changing risk with time. And that's very important because in this case, for instance, infrastructure put into place to protect people, for civil protection, is meant to be in effect for, let's say, 80 years. So if I want it to be a good investment, which survives its payback period, which amortizes, then I have to make sure that it can cope with the conditions that prevail 50 or 60 years from now. And that's why these hazard development corridors are so significant, are so crucial, because that we can look into the future, so that it's possible to refer to different future periods, like the near future, say from 35 to 65, or the more remote, towards the end of the century, 70 to 2100. We get clear answers from this procedure.
So good afternoon, everyone. I'm Alan McKinnon from the Climatologist University in Hamburg. In the interest of time, I think I'll skip some of the preamble and just move into my presentation. So building on what Christoph was saying, one point I will make, if one looks at the impact of climate change on the sort of economic infrastructure of the world, one thing we can do is refer to some of the inventories that get compiled by insurance companies like Munich Re, monitoring the damaging effects of different categories of natural effect, several of which are climate related, like meteorological, hydrological events. And you can see how the frequency and intensity of these events has been increasing, and as a consequence, the insurance costs are rising. And if we look at logistics related infrastructures, take air cargo, for example, it's estimated that around 150 to 200 coastal airports are at risk of sea level rise. Predictions are that by the end of the century, sea level could have risen by as much as a metre. But it's not just the average that goes up, it's the increased risk of storm surges, which can create a problem for airports. And the map at the bottom shows the amount of air cargo handled by some of the airports in the Far East, for example, which are very close to sea level. If we look at the maritime sector, we can look at the vulnerability of some of the world's largest hub ports. Many of them are in the track of tropical storms, hurricanes and typhoons. And as the frequency and intensity of these storms increases, that increases the vulnerability of our global supply chains to climate risk. Just thinking of how businesses have been dealing with this, there was an EU project conducted 7 or 8 years ago called EWENT, which looked at the impact of extreme weather on the freight and logistics sector in Europe. And in the course of that work, they interviewed large numbers of logistics and freight managers to get a sense of how much importance they were attaching to climate-related events. And unfortunately, the results were rather disappointing. They detected a low willingness on the part of many businesses to take climate risk seriously and to make their supply chains more robust. Also, a feeling that they didn't need to learn more about this, that they had the necessary skills to deal with it. But overall, the researchers found there was a poor understanding of the probability of extreme weather events occurring. Also, if you try to take a supply chain perspective on this, companies at different points in the supply chain, I think, had a rather poor understanding of how severe weather events could impact on other parts of the chain. And overall, just an unwillingness, it was felt, to commit enough resources to climate-proof companies' freight and logistics systems. And from my own discussions with logistics managers over the years on this topic, what I've picked up is that many of them see climate change as a longer-term phenomenon and something that future generations can deal with. It's not really an urgent matter, and they've got other more pressing commercial concerns to deal with. And also a sort of almost complacent feeling that weather risk is just another risk factor that can easily be accommodated within the business continuity procedures that they currently have in place. So, but again, if one looks at the statistical evidence that these extreme weather events are becoming more common and their impact on supply chains is becoming more severe. Also, Christoph in his presentation mentioned mitigation. I think currently when you mention climate change to many logistics managers, they immediately think of the need to cut emissions, the mitigation side of the subject. And I'd like just to dwell on the interrelationship between climate change mitigation and adaptation, because if we go back to first principles, you could say that if our mitigation efforts are successful, then we'll have less climate change to deal with, and therefore there'll be less need for us to adapt to climate impacts. At the moment, however, things are very much skewed towards mitigation. If one looks at the investment of climate finance by the development banks around the world, much more money goes into mitigation currently than the adaptation. But right from the start, if one looks at the work of the Intergovernmental Panel on Climate Change, it's been conceded that neither mitigation nor adaptation on their own can deal with this problem. We need a combination of both. But so far, there has been limited research, certainly in the transport and logistics world, on the interrelationship between adaptation and mitigation strategies in this field. And one thing we have to be careful about is that in adapting our built environment, our transport infrastructure to climate change, that we don't do that in a way that emits a lot more greenhouse gas, because the danger is that we create a sort of positive feedback loop, and we get into some sort of vicious circle where our efforts to protect ourselves against climate change end up emitting more greenhouse gases. And also on this subject, it maybe isn't just a two-way interaction of mitigation and adaptation. There's a third element here, which is the amount of damage that we have to deal with. Because with the best will in the world, we're never going to solve the climate change problem by mitigation and adaptation. We're going to have to suffer some of the consequences of climate change. I draw attention here to a paper published almost 10 years ago, which drew attention to this three-way interaction, where the author concluded that given the uncertainties in climate modeling, that it was very hard to determine what would be the optimum mix between mitigation on the one hand, adaptation, and then what they called the residual damage that we'll have to suffer because our adaptation policies are never 100%. Also, I think a point that really is worth making early on is that by applying best practice in logistics and supply chain management over the past few decades. Companies have made their supply chains more vulnerable to climate change. There are a whole series of things which are the sort of textbook recommendations that we should move to hubs and spoke systems, for example. We should centralize inventory to take advantage of the square root law, which allows us to reduce inventories and save on working capital. Focus production, where we concentrate production of particular articles in particular locations. Also that we channel more freight along particular corridors, that we cluster logistical and manufacturing activities in particular locations to take advantage of the agglomeration benefits. But all of these things, although they made perfectly good sense in economic terms, regrettably have made our supply chains more vulnerable to all sorts of risks, but also particularly climate risk. And we could see an example of that back in 2011, when there were severe floods in the vicinity of Bangkok. And near Bangkok, there's a global concentration of hard drive production. So within a matter of days, the world lost about a third of its capacity for making hard drives. Just illustrates how, in global terms, weather events can have a fairly dramatic effect on global supply chains. Now, what do we do about it? Okay, if we look at the United States, although there's a lot of climate change denial in the US has actually done a lot of very interesting work on how we adapt our logistics systems and transport systems to climate change. This diagram comes from a report published in 2014. So on the one hand, on the left-hand side, we've got the climate events which pose a threat to transportation. So we've got extreme precipitation, rising sea levels, spikes in temperature. The first thing we need are to put in place adaptive strategies that minimize the impact of those changes on the transport system. And you can see examples in that box of the things that can be done. But even if we deploy all of these things, we will never contain the problem within the transport system. That transport will always be disrupted to some extent. And so the second set of strategies try then to minimize the wider impact of transport disruption on the freight transport system, on power systems, on people's lives, on commuting, and all of these sort of things. So there's a second set of adaptive strategies there for which aim to minimize the consequences of transport disruption. So it's important to draw attention between these two sets of strategies. But emerging from all of this work is a feeling that the adaptation of transport and logistics to climate change is essentially a problem for the infrastructure planners and operators. They often see it as essentially an infrastructural challenge, and therefore it's the engineers in the end who are going to deal with the problem. But they have a big challenge on their hands. So let's just imagine you're a highway engineer and you're developing a new road in a particular location, and you're wondering what weather tolerances to build in. You want to know, therefore, what the future levels of precipitation will be, what the future temperature extremes will be. Now, the highway engineers have been complaining that the information they've been given by the climate scientists has never been at the right geographical scale for them to make those decisions. But this gets back to a point that Christoph made in his presentation, that what we've seen recently is a downscaling of the climate data, so that the highway engineers who are planning this at a small scale, maybe over a few kilometers, can now get more accurate forecast data on how weather will over the potential lifespan of the asset, which, as Christoph said, can be many decades. So there is certainly progress in this area. But the fundamental problem here is that the statistical distribution of weather is changing. Highway engineers often refer to stationarity, where you make assumptions that the mean is going to remain the same, that the shape of the distribution will be constant, and much of the current highway modeling is based upon that. But climate, of course, is changing that. It's shifting the mean, it's lengthening the tails of the distribution, it's changing the whole shape of the distribution. And unfortunately, therefore, we can no longer simply extrapolate from historical data. And the other thing is that the rate of climate change is accelerating. So there's a constant need to be recalibrating the models. And of course, the big worry that we have is that at some point we will cross tipping points, that there are non-linearities in the way that climate functions. And that's going to make it very, very hard to plan and manage infrastructure in the future. The other thing, again, to give a sense of the challenge that infrastructure managers face in trying to climate-proof their infrastructure, is just the amount of material that's going to be required for climate-proofing. This slide shows the results of some research done by Becker and others, looking at the amount of materials required to climate-proof 221 of the world's largest ports, reckoning that you'd have to put in about 3,600 kilometers of coastal structure to protect these ports against sea level rise and storm surges. They then looked at how much cement that would require, how much sand, gravel, and so forth. They tried to express it in terms of the number of Hoover dams you would have to construct. So, and the conclusion they came to, the quote at the bottom, our initial results suggest that adaptation will be a monumental task and will severely tax global resource capacity. And we're talking only there about 200 odd ports out of 3,000, and this is only one transport mode. This isn't road and rail and all the other. So I just suspect that we're underestimating how much material and how much movement of material will be required to protect our infrastructure against climate change. One other important point is that we have to take a holistic approach to improving the resilience of our freight transport and logistics systems to climate change. In a number of senses. First of all, because the various critical infrastructures are all interconnected. I've spoken here about transport, but we also have to look at the interdependence between transport, power, communication, water, emergency services, because there are close interconnections between them. And if one of them fails, then the damaging effects, the disruptive effects then propagate, they spread, and that's what really compounds the problem. If we need to be holistic, and this is something that Christoph referred to, is across transport modes. Because Christoph said that no mode is safe, but if you zoom into a particular region or corridor, modal substitution may offer a means of improving the resilience of our logistics systems to climate change, because perhaps one transport mode is less damaged than another, and so if you can facilitate modal transfer, that may help. And just to give an example, and this refers back to something that Philip said in his introduction, if one looks at maritime operations, at inland waterway operations in Europe in 2003, year of drought, water levels dropped, and the movement of freight by waterway was severely affected. So one possibility is if we shift too much of our freight to waterways or even possibly rail, and those modes prove to be more vulnerable to climate impact, then we may have a conflict between our mitigation strategies, which is to get freight off-road onto rail and water, those strategies, and adaptation strategies, which might suggest that to make our systems more resilient, we may have to use other transport modes. So the whole issue of modal split and how that relates to adaptation, again, is one requiring further research. And another related issue is the new transport technologies which are currently developing, and their vulnerability to future climate change, because to decarbonize road freight, we're going to have to electrify it by batteries potentially, or maybe having catenary systems over the road network. Now, the batteries will be more sensitive to extreme temperature, the catenaries will be more vulnerable to extreme weather conditions. So drones, if we're going to deliver lots of parcels in the future by drone, then that's essentially a weather-dependent transport mode. So we've got to give some thought to that as well. Other ways in which we need to be holistic is in a multidisciplinary sense, involving specialists from all these different fields. We've got to do it geographically, because weather events extend across regional and national boundaries. And we've also got to do it by stakeholders, because I've made the point earlier that many infrastructure planners and engineers think they are the ones who have sole responsibility for dealing with climate impacts. But that's not true. I mean, I think what we need is a multi-stakeholder approach to this, that the users of the transport infrastructure have a role to play in dealing with climate change. And just to illustrate this, I will refer to tires. Because if you fit winter tires on your truck, you can reduce the risk of the vehicle being held up in snowy or icy roads. I mean, if you put winter tires on, you get about 40% more traction in extreme winter condition. In some countries in Europe, like Germany and Sweden and Finland, it's compulsory to fit winter tires. In other countries like the UK, it is not. In 2010, we had extreme weather in the UK. And the weather was so bad, in fact, there was so much snow that we ran out of grit and salt for the roads. There was then a government inquiry on the subject of what they call winter resilience, how we improve the resilience of the country's transport system in the winter. And if you read that report, at no point do they mention winter tires. The problem is defined and addressed entirely in infrastructural terms. And I think that just overlooks the contribution that the users of the network can make to the system. And I'm almost finished. I've spoken a bit about how we protect our transport systems. What about the buildings? Again, as Christoph said, companies that are building distribution centers now should be looking to future weather conditions over the next few decades during the life of the asset, making sure that they're not in floodplains, for example, or too close to sea level. For the buildings that are currently in existence, again, companies need to do a climate risk audit to see how vulnerable they are to things like flooding and sea level rise. And there are various strategies they might then use. If it's a critical building, they may want to relocate it, or perhaps they can protect it in some way. It depends on a number of things, as I say, on the criticality of the asset and the cost of possibly insuring it. And then my final slide, I think, thinks to the future, where companies may want to reconfigure their supply chains to minimize their exposure to climate risk. Because particular logistics activities have different degrees of vulnerability to extreme weather, and the extreme weather will vary from location to location. So one could construct a matrix like this really to see at what points in the supply chain there is the greatest vulnerability. And there is an increasing amount of data, much of which you can find online, which rates countries and regions in the world in terms of their climate vulnerability, in terms of the extent to which national and regional governments are actually putting adaptation strategies in place. So if one's looking at one's supply chain and discovers that there are certain suppliers or logistics hubs that are being used, which are in locations that are likely to prove vulnerable to extreme weather events, companies may want to address this by reconfiguring their supply chains. I think very few companies are doing this as yet, but maybe once climate change becomes more extreme, that is a strategy that companies may want to apply. Of course, climate is only one of a number of supply chains, and obviously companies will have to balance up these factors in deciding on any reconfiguration of the challenge. And the other thing is that companies are going to constantly have to recalibrate the risk profiles for the different nodes in their supply chain as weather events become more frequent and more extreme. So that's my presentation. I was just going to conclude by saying there is now a large literature on this subject, published by international organizations, by governments. There's a growing academic literature on the subject. On the last slide, I have my email address. If you're interested, I've got a reading list on this area.
We made, as an industrial association, some analysis by seeing if it's possible to reduce our CO2 emissions in the transport sector till 2030 by 40% compared to 1990. And what we figured out is, for example, that shift from road to rail buses, inland water vessels, could at least bring around 7 million tons CO2 reduction of totality between 60 and 70 million tons. And it's roughly around 10%. So generally speaking, if we talk in the logistics world, we often have the impression this could be more, but 60% increase in the transport volume and 35% increase in the passenger volume is quite a lot for the country like ours, and this is considered to be the maximum. If you look at the efficiency of combustion engines or new technologies like platooning, we could, in our estimates, add another 15 million CO2, million tons of CO2 equivalents. But I have to say it's the same way that we count, for example, 20% reduction in the truck sector. So the Commission or the European Union currently is discussing about a reduction of 30%. We calculated here with only 20%, though this could also be much more. But it's not only about efficiency, it's also about the increase of the number of electric vehicles, which plays also an important role with regards to the European legislation. So we calculated a total amount of vehicles between 7 and 10 million electric vehicles, plug-in hybrids, as well as battery electric vehicles. I'm mainly talking here about passenger cars, but also light commercial vehicles and also trucks. So if you talk about trucks, heavy duty vehicles, we have about 120 till 140,000 electric vehicles. So the question is, what is the total amount of vehicles in Germany? So just to give you this number as well, in the range of passenger cars, we talk about 46 million. So 7 to 10 million will be replaced. And we talk about 700 heavy-duty vehicles in Germany, and if we have just a number of 120 to 140,000 electric vehicles over the next 10 years, it's quite a lot. Last but not least, we take also into consideration CO2 neutral fuels, and here these are, together with the electric vehicles, the most important impact from a technological side. Both measures, CO2 neutral fuels and electric vehicles, will bring together around 75% of the needed CO2 reduction. So as you can imagine, this will be very expensive, of course, but on the other hand, take also a lot of time to build infrastructure, to build power-to-X facilities in order to produce CO2 neutral fuels, synthetic fuels, as well as biogas, and this will certainly not produced in Germany. We think this is something we should import, but maybe North Africa is an ideal area to produce such fuels and import it to our country. On the next slide, I will give you an overview. Maybe Audrey can shift to the next slide, please. What we can do in the transport sector, especially in the truck sector. So you see on the right-hand side, the number of trucks, around 720,000 trucks in 2025 compared to currently 737,000 trucks. So he already realized a decrease of a number of trucks due to the fact that we strongly believe a lot of cargo can be shifted to rail and inland water shipping. But it's also necessary to shift to another mode of another technology of transport. And here's a strong example, the e-highway. So in our assumption, we calculated more than 2,500 kilometers of German motorways should be electrified. So currently we have around 13,000 kilometers of motorways. And in the left hand picture, you get an idea of some current test trails we already have in place. Frankfurt, Langen, for example, Neckarsulm, Stuttgart, who is familiar with Germany, knows maybe these areas. But it's also necessary to have a polycentric approach, which means between the main cities, the main logistics hub, to create such kind of e-highways in order to make it possible to run heavy-duty vehicles where it's not possible to bring in trucks with batteries or other technologies. On the same side, we look also at other technologies. Fuel cell vehicles will be very important, and on the right-hand side, you see the average in our calculation, what kind of plug-in hybrids, battery electric vehicles, and also fuel cell vehicles should be brought into the market in order to change something in our carbon footprint. So this is just an idea what should be done in order to reduce the greenhouse gas emissions, and what the transport sector can do. Our analysis is based on the fact that we don't want to reduce the number of transports, or we don't want to reduce the number of vehicles. We want to do it in a more efficient way, and we want to also allow our country to have an economic growth. So maybe you're aware that other analyses talk about consumer reduction and change in our behavior. So this is not the case in this analysis. So we will also handle in this scenario with congestion in the future. This will be one of the major problems. Infrastructure will be one of the big problems as well. But we take into consideration that there's a technical way to pollute less CO2 and to do very quickly something good to our planet. Thank you very much at this point.
Jürgen, thank you very much for that. An excellent finish and some practical examples of work that's being done. We've already gone over the time. Just before we sign off, though, I've got one question that's come through, which probably for Alan. Alan, the question is, given that a lot of the climate change is derived from industrial development in Asia, how much dialogue is there going on, and how much research, either jointly or independently, with Asian academics? Is there a combination there or not?
There is some, yeah. Last year, or 2 years ago, I was at a conference in Beijing that brought together academics from a number of Far Eastern universities focusing on green logistics and sustainable supply chains. And there were a significant number of academics from the West there as well. So it was a sort of meeting place for people working in this area. I mean, to some extent, we all face different research challenges, but I mean, we have a global market for research these days, and there's wide dissemination of the results and there are various collaborative programs. So I think we're seeing, you know, the transfer of results and theories, and you know, so I think that's quite a healthy interaction we're having with Far Eastern academics. Yeah.
And do you see the dare I say it, complacency that you referred to earlier on, all around the world generally, or?
I think so, and it's perfectly understandable. I mean, all business people have got financial targets to meet and sales targets, and many of them are short term, and so that's simply what dominates people's thinking. However, I mean, I don't want to be too negative about it. I mean, it's maybe worth distinguishing adaptation from mitigation. You know, I think there is a lot of industry engagement these days on the mitigation front. You know, with you know, international organizations, individual companies. I mentioned a few like Unilever and Procter & Gamble that have got sustainability strategies in place. And that's all very encouraging. To some extent, I think the business community is ahead of many governments in this respect in their efforts to try to drive down carbon emissions. So where I think my complaint, my presentation was more at the adaptation side. I think there is a reluctance to face up to the fact that a lot of supply chains are going to prove quite vulnerable to climate change. And I think there's just more work needs to be done on the adaptation side. But no, I think business, and we'll probably see this in Hamburg, you know, when FNL companies attend, I think companies are becoming increasingly aware of the challenge that climate change faces. Getting the balance between mitigation and adaptation slightly tilted, you know, to devote a bit more thought to how you adapt to this.
Thank you, Alan. Thank you very much to everyone for joining us. I hope you found it useful, plenty of food for thought and much to read. We will make the presentations and the slides available on the FNL website. And we very much look forward to seeing you in Hamburg to continue the debate. So finally, thank you to Christoph, Alan and Jürgen, and we look forward to seeing you all in May. Goodbye.